On this first item of the exam, we've got a truss that we're asked to analyze. We're going to find three different member forces, CD, CF, EF. They're already marked here with an X. They're all on the same panel. That means that we can presumably find all three by cutting through the section of the truss right there. And that's, of course, how we're going to go after this. So let's get the simple part, which is the right half of this, and get each of our pieces in there, and then we will come along and get our reactions at 6252 and 4004 for the lateral. We've got the applied force at D of 4,000 going downwards. Guess that we have tension in the bottom chord, CD. Guess that we have compression in the web, CF. And guess that we have compression in the top chord, EF. Right. So there's our three forces. And we got a non-concurrent force system, so therefore we got three equations of equilibrium that we can use. And that's where we'll then make our next step here, is to write equilibrium equations and get after this. So if we are clever here, we could probably find a nice simple way to do all this. If we go look at F, we get EF and CF that will go right to the point. 4,000 goes through that point, and we're only left with two reactions in CD. It seems like a really good place to start off this test. So let's moments about F. We'll take clockwise as positive. We'll have the moment arm of 1.5 for CD, and then we'll have minus 6252 times 3 meters, and then plus 4004 times 1.5 meters is equal to 0. And when you conduct the math there, you'll find out that CD will be a positive number of 8,500. That means it's going in the direction as shown. So therefore, CD equals 8.5 kilonewtons in tension. Right. Next, what we can do is find another place where forces will intersect with each other. How about over here at B, where we get both reactions, CD and EF will go through that point. That's awfully doggone convenient. So let's some moments about point B, and let's see, we get the minus 4,000 times 3. That one's gone. That one's already gone. That one's gone. Let's see here. And, oh, hey, holy schmoly. We left off a force here, didn't we? We left off that 2,000 Newton force. Does that mean we're going to have to start all over? Oh, hey, that goes through point F. I got lucky, but that mistake, I got lucky. Whew. Alright, so now we get plus 2,000 times 1.5. That's the moment arm down to B. And then we got to figure out what to do with CF. I think what I'm going to do is slide it along its line of action up to here at some fictitious point, and that's right directly above point B, so that when I break it into CFY and CFX components, then I only have to include the X component. And so that's an easy moment arm, 1.5 up to that horizontal line, another 1.5 means that we have plus 3 times CFX equal to 0. And work the math on that. We find out that CFX is equal to 3,000 plus. Right, so we guessed the right direction. And then that means that CF, look at the proportion between the horizontal and the hypotenuse, so square root of 5 over 2 times that X component. And so we will find out that, therefore, CF is going to be 3,354, or it's 3.35 kilonewtons. It's shown in compression. We had positive result here, so we guessed that correct as well. And then finally, we need to get EF, and so there we can come along and we get some moments where CF and CD intersect. That's point C. So if we, some moments, well, point C, let's take clockwise positive one more time, and we get minus 4,000 times 3 plus 6252 times 6, and then minus 2,000 times 1.5. Check on those. That would be a plus 2,000 times 1.5. And then we'll take EF, we'll take it down to point B. We'll take the X component will pass through C, so we only need the Y component. That'll be a plus EFY times 6. Set that all equal to 0, and we find out that EFY is equal to 3752. To find then EF, we got to go find in this ratio here 1 to 2 to the square root of 5. We've got the Y. We need the hypotenuse, so square root of 5 over 1 times 3752, and we'll get 8389.7. So therefore, EF is equal to 8.39 kilonewtons. Shown in compression, we got positive results, so that will be compression there as well. And there you go. There's our 3 answers.